This is my entry to the Moog Circuit Bending Challenge 2016, and it's called the V-System sequencer. And what it is, it's a step sequencer with 8 steps. So it uses these kind of sound cartridges, and each cartridge is built from a toy, and the toy is stripped down so that there's only the PCB inside, and you can change the sound by using different cartridges. So there's a for example, there's a drum toy on one of these, and one that just says animal sound. And the sequencer has a pitch control, so you can change the pitch of the toy. And if it has more than one sound, you can change the sound with these selections. So there's up to 4 different types. And there's also an echo control here that you can put an echo on. That's made from a Circuit Bend quiz game. You can have the feedback and the rate and the volume, and there's some distortions from the Quizit game also. And the controlling of the sequencer is made by using these breadboard wires. So you can change the way the sequencer works. So it doesn't have to be from left to right. It can go randomly depending on how you put the wires in. And also you can have more than one hit of the sound per step, so you can have like 4 on each step. On the back there's places for external clock and 2 external modulators coming from somewhere else, and there's 2 different audio outputs. So this is for the headphones, and this is the mono output. You can modulate the pitch as well with the external ones, or there's 2 LFOs built in. So you can modulate the audio pitch frequency, and you can modulate also the volume, and that's it. The concept is to combine a step sequencer and sound cards made from different toys, something like this that I bought this morning. So every step it would like press the button. Sequencer would use these kind of sound cards that would plug into the sequencer, maybe using something like these header pins. The sequencer would have 8 steps, and each step would have a rotary switch, something like this. If the toy has like 4 buttons, you could change what sound it is. If it has less, then it would be only like 1. And each step would also have a potentiometer that you could change the pitch of the sound. So you could get different types of sounds with the same sequencer. So you would have many of these, and this would control the sound parameters of the sound card. Sequencer would be a semi-modular kind of configuration. So it would use the CD405 chips, 3 of them to control the LED, 1 for the LEDs, 1 for the pods, and 1 for the sound card buttons. 40404 for the data, for the 405 ones, and it would use 40106 for the clock, and maybe for some LFOs to modulate the sound or something. And it could also have a clock coming from outside as well. So you would get the clock source coming for the 404, and then you would have to put them into the data lines of the 405, but you could change the data lines to make it go random and different types of things, so it wouldn't have to be the straight one, it could go randomly. And the same goes to this also to the sound control, so you could get it to come up with every clock pulse, so it would be like 2 on each step, and maybe some other things that I could add to it would be maybe a filter or tape, cassette players, type of fuzz or delay, and maybe a joystick to control some of the parameters. We'll see. The buttons would work that there would be a transistor soldered to the place where the button used to be, and then there would be some pulse coming from the sequencer to turn it on. And for the enclosure, at the time I'm thinking maybe using this used to be a phone. It has this kind of nice shape, and maybe repaint it or something, and maybe use laser cutter to make the new face plate or something. I'm not sure yet. So the 5th annual Moog Circuit Bending Challenge. I have to check how much is $70 US. 70, and let's see how much it is. So I have 62.47 euros to spend on this project. Today I went to the recycling center and I got this Quiz It music game. I think I could maybe use in my circuit bending challenge project. So and the reason why I took it was that it had these distort buttons, and the first one just cuts the signal off. And the second one, it just makes this random kind of noise on top of the signal. And the third one, it's the most interesting. It does this kind of oscillation, kind of robot voice kind of thing. So inside this Quiz It game, there's a 2399 chip. That's the same as the PT one, and it's an echo chip or a delay chip. And so I can see what I can do with this one. Maybe I can do some bending on it to make it sound more interesting. Sound card I will use 17 or 16 pins, but I need 2 pins for each button, so I don't need to use a transistor in every one of these. 4 transistors, so I can just use 4 transistors on the actual sequencer. The actual shape of this will be something like this, so you can't put it in the wrong way around, because if you would do that, it would probably break either the sound card or the sequencer. So if the hole will be shaped like this, then you can't put it in the wrong way around. Here's just a simple 40106 LFO pushing turning on the transistor that turns on the sound, the same as you would push the buttons on the toy. And you can adjust the speed just to test out the circuit with the transistor. This is the sequencer running with 4 potentiometers and 4 resistors controlling the pitch. And the toy that's in here, it's every time you press the button it changes the sound. I don't know how many different sounds there is, but and you can change the pitch. So this is how it's going to look. So these are on every second step, these potentiometers, and you can change the tempo as well. Here I am at the old Fab Lab, and I'm taking stuff from the trash that's free to use, so I found these pieces that I can use in my project. Now I have to stain them. Here's the stained wood. I put some masking tape over it, and now I'm ready to cut it with the laser and engrave it at the same time. Here are the finished faceplates that had been laser cut, and I put clear coat on it. The finished box from the old phone, and it has a base coat and a black matte finish and 2 layers of matte lacquer on it. Just super glue these pieces together. I'm just letting the glue to settle, and I had to use tape because of the bends of the box, so it was too hard to hold with just your fingers, so I had to use some tape. Here's the box all glued together and the gray bottom washed. I cut the headers for the cartridge. It was 20 pins and I only need 17, so I cut it down. I still have to file it a bit, and now I'm getting ready to solder it to the breadboard, but I still have to figure out how to put it, where to put it, and how to get it to these holes here. So I have to cut something here inside, and I'll also put the LEDs to see how they look, and they're white LEDs. So I'm thinking that white LEDs up here, and these LEDs will be colored depending on which they use. So I might use different LEDs for different things here. Found this toy today at the recycling center, and I will probably make one sound cartridge out of this.
Colors, numbers,
using these 3 buttons. Wires. Lots and lots of wires. Now I have to start and putting them into the right places. I'm powering the sequencer from 4 AA batteries, and I will take the 6 volts from all of them, and then 4.5 from 3, 3 from 2, and 1.5 from 1. I can take power to any battery operated toy that uses any of these, so it doesn't matter which it is I can use. Of course nothing over 6 volts, but I think most of them that I will use are just under 6 volts. Wires, lots of wires. Lots of still to do. Now the wiring is done. Time to put the batteries and hook it up and see if it works. Okay. Something's a bit off, apparently. There's no volume. It kind of works. Well, at least it's doing something. The sequencer is going the right way and acting as it should. but I think I burned the toy because it touched the other side, so I'll have to change it. But the sequencer is doing what it's supposed to. It's finally finished. The box is ready and it's working, and all I have to do now is to put the knobs and make the cartridges for the toys. I have one toy ready and I think I have to do a few more. I'm going to try and do the drum sequencer out of this one, just using the drum bats, and we'll see how it works. I think this was something like €2 or €1, something like that. Now I'm making the cartridges. I drilled holes already to the PCB, and then I'm just going to measure the right place and then drill holes into the cartridge and then put it in.